So we will talk about today in units of energy and work. So 1 joule equals to 1 kg meter square second square inverse. This is equal to 1 Pascal meter cube. Now what is this 1 Pascal? 1 Pascal equals to 1 kg meter inverse second square inverse. So you remember this. 1 Pascal equal to 1 kg meter inverse second square inverse. Now as you all know, W is equal to minus P external into delta V. So if P is expressed in bar and delta V in dm cube, so the unit for this work done will be W is equal to bar dm cube or dm cube bar. Now there is one more thing, that is 1 bar equals to 10 raised to 5 Pascal, and here 1 Pascal equals to 1 kg meter inverse second square inverse. So we will substitute here 10 raised to 5 and here substitute the value for this Pascal, which is going to be kg meter inverse second square inverse. Now 1 dm cube bar means if work done is expressed in dm cube bar, that will be equal to dm cube into 10 raised to 5 kg meter inverse and second square inverse. So this is this thing we are substituted here into dm cube, because this 1 bar is equal to 10 raised to 5 Pascal and 1 Pascal equals to this. So we come across this thing into dm cube. So that will be dm cube into bar here. Now replace this dm cube with meter cube. Meter cube into 10 raised to minus 3, that will be again into equals to dm cube. Remaining will remain the same into 10 raised to 5 kg meter inverse second square inverse. Now this 5 minus 3, it's going to be 10 raised to 2, that will be 100, that is 100 kg. Now here it is meter cube and here it is meter inverse, so it's coming out to be meter square, and we are left with the second square inverse. So we will reach up to this either 100 or 10 raised to 2 kg meter square second square inverse. Now here I wrote initially 1 joule is equal to 1 kg meter square second inverse. So instead of this you can write 100 joules. So these are the units for energy and work. So when you solve the problem, you will remember this, all these units and the interconvergence here. Now we'll come to the next concept, that is of maximum work. So maximum work, here we will write maximum work. What are the conditions for this maximum work to be obtained? Because ultimate aim is for the any chemical reaction or for any system that it should give you the maximum work. So when opposing force, this opposing force, that is P external, you always remember this. Opposing force means the P external, that is external pressure. When it reaches its maximum, the system will perform maximum work. The system performs maximum work. So condition for this maximum work, that this opposing force should reach its maximum, performs maximum work. Now maximum work. Secondly, when, this is first thing. Second, you can write when opposing force, that is P external, when opposing force, that is P external, becomes greater than driving force. So what is this driving force? Driving force, that is the pressure of gas. Driving force is nothing but this driving force is the pressure of gas. Means if you take a container and if you take a sample of the gas and it is fitted with the piston, so this gas it has its own pressure that is called as the driving force. This is driving force, and if you are applying or putting some mass over here, that can be called as the external pressure or the opposing force. This is also opposing force. Now if P, pressure of the gas, this is the P, this is the pressure of the gas, differs from P external, this is external pressure, by a quantity delta P, then P minus P external will be equal to delta P. Now work would be maximum when delta P is smallest. Means if this pressure of the gas is suppose 10, I am not putting here any unit in front of this. If it is 10 and P external, if suppose we say this is 9.5, means it has very small difference, that is 0.5. If this difference is very small, then only there will be a maximum work. Now remember, this pressure of the gas, it is exerting in this direction, and the external pressure, it is applied in this direction. So when these two forces, they are having the same magnitude, this piston will remain at rest. And if there is a small difference, means if pressure of the gas is little bit more than the external pressure, this will be lifted up with a very small amount. With a very small amount. This lift is very small here, and this is nothing but the reversible process. If you again increase the pressure from the outside, this will again come down to its original position. It means that the reaction can be, or the process can be reversed here. So this is happening in number of steps. So if this is happening in number of steps, then only you will get the maximum work here. So to get the maximum work, the reaction or the process should be reversible. Work would be maximum when delta P is smallest. So this delta P, that is P minus P external, should have very small value. It would give you maximum work. Work would be maximum when delta P is smallest. Delta P would be smaller than opposing force, is infinitesimally smaller than driving force. Means this change or this difference in the values between the opposing force and the driving force should be very, very small, that is infinitesimally small. Then only you will get the maximum work. So this is required for the process to be reversible. Means there are two things arises. The process should be reversible, then only you will get the maximum work. For that thing, this delta P should be very small, means the difference between these two opposing pressure and the opposing force and the driving force, this difference should be very, very small. Okay, so this is about the conditions for getting maximum work. Thank you.